Okay, let's check out these questions that relate to bonding. These would be the short answer questions from the Regents exams, the 3 Regents exams from 2015. Let's take a look at number 1. All right, so we're looking for what's called the empirical formula for glucose. Of course, you have to know the definition for empirical formula. That's your lowest whole number ratio of the different elements in a compound. And you're given what's called the molecular formula for glucose as C6H12O6. So all we're looking to do is to simplify it to the lowest whole number ratio. And of course the greatest number here that we can divide through by is 6. So we end up with CH2O. That's our answer here for number 1. Alright, in number 2 and 3, we have this table here that we have to check out. We got boiling points for 4 different compounds, and let's go to question 2. Identify the compound that has the strongest intermolecular forces. Well, if you have strong forces between molecules, it's going to take more energy to break them apart, which means, of course, you're going to have a high boiling point. So the highest boiling point of the 4 is water. So guess what? Water is your answer. Let's move on to number 3. Explain in terms of molecular polarity. Anytime you're asked to explain in terms of something, realize that's what they're looking for in the answer. So I have methanol in water, and the solubility they're saying is greater for methanol in water than the solubility of methane in water. Well, methane is up here. If you notice, it's a very symmetrical molecule that makes it a nonpolar molecule. Polar, I can't spell. And of course, methanol has an OH group, and that makes methanol polar. Water, you always want to remember, of course, is polar. In fact, water is so polar when water bonds, not bonds, but when water molecules are attracted to other water molecules, because it's this super duper polar molecule, it's called hydrogen bonding. But any polar molecule would like to dissolve with another polar molecule. There's an old adage your teacher might have mentioned to you that says like dissolves, like, and that means polar wants to dissolve in other polar molecules and nonpolar in other nonpolar molecules, and they don't want to mix. So, finally, getting back to question 3, the solubility of methanol in water is greater because methanol is a polar molecule and methane is a nonpolar molecule. Alright, let's check out some more questions. Question 4, we have here a Lewis electron dot diagram that's supposed to represent sodium chloride, and you're asked to explain why this diagram is not accurate for the bonding in NaCl. Well, NaCl, of course, sodium is a metal, chlorine is a nonmetal, so the type of bonding here is ionic. Notice the word ion. That's because with ionic bonds, there's the transfer of electrons. So, what the student should have done is show sodium ions and then chloride ions. Now, it's said to explain why, so I don't think they're looking for you to rewrite the diagram, but just to say that you need to show the charges for sodium and for chlorine, because, again, it's an ionic bond in NaCl. Alright, let's check out number 5. State in terms of molecular polarity. Well, this is the second time a question like this has come up already in 5 questions. Why ethanol is soluble in water? Well, again, always remember, water is a polar molecule. Polar bonds, polar molecule. Ethanol, then, if it's dissolving in water, must be polar. So, ethanol, again, is soluble in water because they are both polar molecules. Check out part 2 for chemical bonding. We'll start here, and in the next video, we'll start with question 6.